Hello students. Video lesson 5.3 has to do with that second type of sequence that I told you we would talk about, geometric sequences. A little different than arithmetic sequences, which have a common difference. But before we talk about geometric, let's just review arithmetic. So the common difference again is when the difference between consecutive terms of a sequence is the same. That constant rate is called the common difference. So finding the common difference here in this first sequence, it goes from 4 to 2, from 2 to 0, from 0 to negative 2, making the common difference minus 2. In this second one here, it goes from 3 to 3.25 to 3.5 to 3.75, giving you a common difference of 3/4 or 0.75. Tomorrow in class, we're going to practice writing explicit and recursive formulas for geometric sequences. But let's just real quick review how to do that for these two arithmetic sequences. The explicit formula for this sequence would be a of n is equal to the first term of 4, take away 2, times n minus 1, and n is greater than or equal to 1. The recursive formula for that same sequence would be the next term, a of n plus 1, is equal to the prior term, a of n, minus 2, where n is greater than or equal to 1, and where the first term, a of 1, is equal to 4. For the second sequence here, the explicit formula would look like this. A of n is equal to 3 plus 0.25 times n minus 1, and n is greater than or equal to 1. Recursively, it would look like this. The next term is equal to the prior term, a of n, plus 0.25. n is greater than or equal to 1, and the first term, a of 1, is 3. A little review, because I know how much fun you had last class writing those formulas. So here's the new stuff. Geometric sequences. Geometric sequences have what we call a common ratio. We're going to call that lowercase r instead of a common difference. That means to get to the next term in the sequence, you multiply by a common ratio. So to find the common ratio, just divide, for example, a2 by a1. Just take one term and divide by the one in front of it, especially if you can't notice what the multiplier is right off the bat. So here's an example, 5, 10, 20. If you do term 2, 10, you divide that by term 1, 5, you get 2. If you do term 3, 20, and divide by term 2, 10, you still get 2. So this has a common ratio of 2. So when you take your test next week, you'll really have to think about when you're given a sequence, is it arithmetic or is it geometric? You have to look at the pattern. Is it adding or subtracting the same amount each time, in which case it's arithmetic? Or is it multiplying by a common ratio, in which case it's geometric? So let's look at some examples. We're going to determine if the following sequence is arithmetic, geometric, or neither. We'll just put A, G, or N. And if it is arithmetic or geometric, we're going to state the difference or the ratio, D or R. If you look at the first one, 16 minus 8 is 8, but 8 minus 8 isn't 4, so it's not arithmetic. However, 16 times 1/2 is 8, 8 times 1/2 is 4. So this is a geometric sequence with a common ratio of 1/2, because that's what you're multiplying by to get the next term. 5 plus 6 in number 2 gives you 11. Does 11 plus 6 give you 17? And 17 plus 6 give you 23? And 23 plus 6 give you 29? It does, so this one's arithmetic. The common difference being positive 6. Number 3, 16 minus 12 gives you 4, but 4 minus 12 doesn't give you 1, so it's not arithmetic. 4 divided by 16 is the same as 1/4, so 16 times 1/4 gives you 4. Does 4 times 1/4 give you 1? And it does. This one is geometric with a common ratio of 1/4. This next one, 5 plus 10 is 15, but 15 plus 10 isn't 45, so this one's not arithmetic. 15 divided by 5 is 3. 5 times 3 is 15. Is 15 times 3 45? It sure is, so this one's also geometric with a common ratio of times 3. For number 5, 20 minus 4 is 16. Is 16 minus 4 12? And is 12 minus 4 8? Yes, it is. So this one's arithmetic with a common difference of -4, because you're subtracting 4 to get from one term to the next. 1 plus 1 is 2. 2 plus 1 is not 4. 4 plus 1 is not 16, so this isn't arithmetic. 1 times 2 is 2. And 2 times 2 is 4, but is 4 times 2 16? No, 4 times 2 is 8, so guess what? This one is neither arithmetic or geometric. This would be a capital N for neither. So what I'd like you to do now, and this is what you're going to show me for a grade when you come into class next time, is just try the examples below, doing the same thing we did above. And when you come into class, you can take this out. I'll come around and check it and give you credit for doing it. See you tomorrow.